Well, hello, all my students out there. Tuning in for Jessica Langbart with your review for Section 13. Here's your key. Hopefully you've been good and been doing your homework. If you haven't, I don't know what to tell you except for the end of the quarter is upon us. So hopefully you're going to rock this test, if anything. All right, so question number 1. The diagram shows circle P, the diameter of BD, inscribed triangle BCD with PC as 8. So I'm going to put PC as 8. All right, there we go. PC is 8. Measure of CBD. So this angle right here is X degrees. BCD right up here. This whole thing is X plus 48. Okay. And then they ask you to find X first. Okay, so, I mean, a few things to note. This is a triangle, which is nice. So we might get to that later, but you guys kind of talked about an inscribed angle. So if I had to use a highlighter, which I will, I always refer to this as the ice cream cone. Here's your cone. It's just upside down. And then your ice cream is right there around the circle, right? So old school, or maybe even better than an ice cream cone is an icy. Okay, so they got it upside down, and I always want more ice cream than I want cone. So a way to remember this is that if you double the angle of the cone, it is equal to the ice cream on top. I'm talking about degrees. So in any case, thinking about this, well, this is the diameter. That's 180 degrees out here. All right, because it's half the circle. So that ice cream would be doubled. So if I take half of 180, that would give me this measure right in here, which would be 90 degrees. So what we're going to do is we're going to set this little guy, X plus 48, equal to 90. All right. Again, that would be 90 degrees. 90 degrees. So again, ice cream is double the cone. All right, cool. So then right here we solve. Okay, subtract 48 to the other side. X is equal to 42. Well, easy peasy, lemon squeezy. That's 42 degrees. Okay, so we got that first part, 42 degrees. So then it says the length CD is, and then it gives you some responses. So CD is right here. Okay, so that's part of another cute little triangle here. Oh, look at that. This is a diameter. Half the diameter is a radius, which would also be 8, which means you have an isosceles triangle here. Okay, if you have an isosceles triangle, then we can deduce a few things, like the base angle right in here is going to be the same angles over here. Okay, cool. What else, and how does that really truly help us? Well, you knew that over here was 42. We knew this was 90 in the grand scheme of the big triangle here. All right, so we knew that was 90. We knew this is 42. We could figure out this angle, which is right in here. 90 plus 42 subtract from 180 is 48. So I actually know this angle right here is 48 degrees. If that's 48 degrees, then that means this chunk of the little triangle here, that's also 48 degrees. Okay, so if I want to know the angle over here, again, in a triangle there's 180 degrees. Let's just go 48 plus 48 and subtract that from 180. That would get you 96 degrees right here. All right, so now if you're trying to figure out which, well, this bottom piece here, which I'm not quite sure the 70 degrees are coming from, just a heads up. But if I just look at that small triangle, so I'm just going to redraw it right here. It's isosceles. We know this is 96. We know this is 48, and this is 48. Oops, sorry. Okay, so we know this is C, we know this is D, we know this is P. They said down here the length of CD is 8, less than 8, greater than 8. So CD is right here. Well, you know this is 8 and this is 8. Now, it's not going to be 8 because it's not an equilateral. Otherwise, we'd have all equal angles. We don't. So it's definitely an isosceles triangle. Okay, so what's more than that? We talked about that hinge theorem. So the angle relates to the side directly across. So like 48 relates to 8. 48 relates to this 8. 96 relates to the side CD. So if I have a bigger angle, then the side across is going to be bigger than whatever the other angle across from the side was. So since 96 is bigger, I know it's going to be greater than 8. All right, so if I come down here, I know CD is going to be greater than 8. All right, and then it says because response is triangle CBD is equilateral. Well, no, all the angles aren't equal. The measure of CPD is less than 70 degrees. So again, I know where 70 is coming from, but CPD is not less than 70. It's greater than 70. So if I look at the last option, measure angle CPD is greater than 70, there's my answer, boom. I mean, it's 96 degrees, so that's greater. All right, number 2, 2 chords intersect with the measure shown in the drawing. I know there's a little space there. It's not supposed to have a gap. That's okay, no big deal. Okay, there's one little theorem that talked about, so basically you just take one chord here and you multiply one side of it times the other. So 5 times 50, or 11, sorry, is equal to, and you do the same thing with the other chord. So we're going to take 5 times x over here, set equal to 5 times x. And then we solve. I mean, essentially you're just going to divide both sides by 5, but if you just want to go ahead and do it, it's 55 is equal to 5x divided by 5, and x is equal to 11. Boom shakalaka, you are done. All right, rolling on to the next question. My mom's here, so she might laugh at me, and that's okay. All right. Point B is the center of a circle. AC is the diameter of a circle. Whoa, freeze. I need a picture. You know me. Got to have a diagram always. All right, so here's your circle with center B. And AC is a diameter. AC. Okay. Then we go back here. It says point D is a point on the circle different from A and C. Okay, so I'm just going to put D like right here. Like, I don't really care. Evaluate the statements below and mark if they are always true, sometimes true, or never true. Okay. Here we go. It says arc AD is greater than arc CD. Well, let me look. So arc AD in my diagram, here's arc AD. They're saying it's greater than CD. Now, I placed my point D here. It could have been over here. So I'm going to say on that one, it's sometimes true. All right, depending on where you put your D, it's sometimes true. All right, next one, measure of CBD. Okay, so let me find CBD. So we're talking about this arc right here. It's equal to half measure of CAD. Okay, let's find CAD. So CAD. Okay, so I'm going to go ahead and draw a line right here to indicate this angle. Okay, so we're saying that CBD is equal to half of this angle. Well, remember right here, CBD is a central angle. So whatever this angle is would be what's up here. So again, when I look at this, I see an ice cream cone right here. So this is the cone. Here's your ice cream. What I know about the cone is that it's half the ice cream. Okay, cool. So let's just pretend with some arbitrary numbers, right? So if the ice cream here is 100, that means the cone over here would be 50. Okay, the central angle is the same measure as what that arc is, so this would also be 100. So if I like use this and I go back and look at this, it says measure of CBD. So CBD, this arc right here, this angle is 100 degrees. It's equal to half CAD. All right, so if I took half CAD, that would be 50. So I think they have that flipped. So what it should say is this: if we took half of CBD, if I took half of CBD, so half of 100, that would equal CAD. Yeah, so that one's gonna be never true. Darn. Okay, next one, CBD. Okay, so CBD is right in here. They say it's equal to 90 degrees. Now I just came up with 100, right? That was just an example. It could be 90 degrees, but they don't give us any number, so that one's just going to be sometimes true. All right, and then over here, measure of ABD. Okay, so ABD is right here, this angle in here. It's equal to double CBD. Okay, so CBD. Okay, so they're saying that if I took this angle in here and I doubled it, or is going to be equal to this angle doubled. Not necessarily. It could be, so that's going to be sometimes true. All right, next one. So then with the same thing, it says BDA. All right, BDA, so this angle up top, is equal to 10 degrees. What is the measure of CBD? CBD. Okay, so I'm going to redraw that one for this just because it's getting a little bit messy. Here's my B. Here's A, here's C, here's D. Okay, so they said BDA on this question. BDA. BDA is equal to 10 degrees. What's the measure of CBD? CBD is right in here. What is this one? Okay, well, note B is the center of the circle, so this would be a radius. This would be a radius, which means this would be an isosceles triangle. Pull it, tick here and tick here. So our base angles, right? These are your legs. Your feet are down here, and they're the same like 10 and 10. All right, so if I want to know this angle, man, that's easy. 180 degrees in a triangle. Subtract 20. This is 160. And then on a line, there's imagine that 180 degrees again. So this is 180. I'm going to take 180, subtract 160. I'm left with 20 degrees on there. Now, obviously, my diagram is not drawn to scale because they didn't ever tell me where to place D. I just put it arbitrarily wherever I wanted to. And so we're going with 20. Do I see it over here? Fantastic, I do. All right, number 4. What is the measure of RT in the figure below? Arc RT, that is. What's the measure of arc RT? Fun. Again, I do this ice cream all day, every day. All right, so like if I just pointed out right here, this is 90 degrees. Your cone are the 2 chords that connect, right? So this is your cone. The ice cream is what's on top, and it's kind of like, you know, about to fall out. Right, there's your ice cream. So I know this is 90 degrees. Again, I always get double the ice cream. So if I double 90 from S all the way to R is 180 degrees. Cool. This is a rectangle, so if this is 30 degrees, imagine what this is going to be from S to T. 30 degrees. Crazy. Okay, so if I know from S all the way to R is 180, that means from T to R, we just subtract those, and it's 150. That looks bad, but it's 150. Okay, cool. So whether they ask, what's RT? Boom shakalaka, it is 150. They're at D. El numero 5. All right, now this one's fun. And by fun, I mean, let's do this all the time. It's great. Find the measure of the indicated angles in circle O. So here's your circle O. I'm gonna go ahead and connect these lines because it's, there we go. Okay. Okay, so we got to figure out, select all statements that are true. Oh, so that just means we got to find everything. Again, start with the ice cream cone. So like you see 56, that's right there, the base of the cone. It's upside down, so here's your cone. Here's the ice cream. So again, I always want more ice cream because that's just me. So we double 56. If we double 56, that is 112 degrees. So from here to here, it's 112 degrees. Don't mind my husband playing something over there, crazy. Okay, so if you want to know right off the bat, what's easiest is the central angle because it's the same degree. All right, so B, right, so you see this line here and this line here, it's the same distance around the circle, so that is 112 degrees. So B is correct. That's circle B, that's true, but it's got to keep going. This is multi-select. What else could you do? I mean, right off the bat, I see that C is on the other side of this point O, and on a line, there's how many degrees? 180. Isn't that fantastic? So if I take 180, subtract 112, that is going to give me 68. Okay, so C would be 68 degrees. Is that correct down here? Fantastic, it is. We keep rolling. Okay, what about A? Okay, so... well, while I'm at it, so if I know this angle of this arc from here to here is 112, note halfway around the circle is 180. So what I would do is just take 180 again, subtract 112. And if I took 180, subtract 112 again, that's 68 degrees. So the arc from here to here is also 68 degrees. Okay, how does that help? And again, that's across the central angle. Okay, how could I find A? Well, if let's see, C is at 68 degrees. You've got